In this video, we're going to introduce the idea of composition. We won't actually perform composition until the next video, but we'll try to get a handle on what it does. It sometimes makes sense to perform one function after another. For example, suppose you had the following pair of functions, the first of which we'll call capital R of t. And what we're imagining here is an inflating spherical balloon. And this function, as the balloon inflates, its radius is going to increase. It's going to take as its input it's going to take as its input the time that we have spent inflating the balloon, and it's going to give as its output the radius of the balloon. Very well. Now let's define a second function, v of r. This balloon is a sphere. It's got a radius and a volume. And we're defining a volume function that takes the radius as the input and gives you the volume as the output. With these two functions together, it should be possible to find a new function, a third function that takes as the input time spent inflating the balloon and gives as its output the volume. Because suppose you're given some specific time. The first function lets you use that time to find the radius. And once you know the radius after 2 seconds, you can use the second function function to find the volume after 2 seconds. So a diagram of this would look like this. You start with time. You use time to find the radius, and then you use the radius to find the volume. And these functions were named, I believe, capital R and capital V. This first function was R. This second function was V. We want to create a third function that bypasses the radius and just goes directly from time to volume. This is the composition of these two functions, and it's written like this. And take warning, composition is written in the reverse order than you might expect it to be. If you follow this process, first capital R happens, then capital V happens. The way composition is written, the second thing that happens is written first. The first thing that happens is written second. And there are a bunch of examples we could think about. For example, let's define a function C of t that's going to take as its input the temperature in degrees Fahrenheit and give as its output the number of cans of soda sold over the course of the day. Let's make this the maximum temperature achieved during the day, just so there's no ambiguity. And we can define a recycling function. The more cans of soda are sold, the more cans of soda are out there. So pretty trivially, the more cans of soda will be recycled. This function will take as its input the number of cans sold and give as its output the number of cans recycled. And just like this, we can create this diagram. We start with temperature. use this first function to find how many cans were sold. Then use this second function to find how many cans were recycled. And we'd like to bypass this middle step. We'd like to go straight from beginning to end. This is composition, and composition is written in reverse order. Second function written first, first function written second. Next, we'll learn how to perform composition.